say hi to Jackson. He's going to be joining us today for the video because, as you can probably tell by the cone, he is not feeling the best. So, as I take care of him today, I thought it would be fun to do a more low-key video and look at some outer space facts, because I did a poll on my channel and like half of you said that you like learning about outer space, which I thought was surprising because I actually haven't covered any videos really on outer space. So I was like, well, we gotta fix that. I actually don't know very much about outer space. I took an astronomy course in college. That was pretty fun, but it was like intro to astronomy. I learned a lot of cool stuff, but I thought for today, let's do a Google deep dive into outer space and learn some cool stuff together, and I'm excited, so let's go. All right, so quick crash course on our solar system. We have 3 different types of planets, and when I say 3 different types, I mean 3 compositionally different planets. We have the terrestrial planets, which are Mercury, Venus, Earth, and Mars. They're called terrestrial because they have the root terra, which means land, Earth. Second, we have the gas giants, Jupiter and Saturn, which are made of hydrogen and helium. And finally, we have the ice giants, which are made of heavier elements than the gas giants, things like carbon, oxygen, nitrogen, and sulfur. Mercury is the fastest planet in our solar system. He is named Mercury after the speedy messenger of the ancient Roman gods, aka, if you're a Greek mythology buff like me, Hermes, but the Roman name is Mercury. And apparently, Mercury is the fastest planet in the solar system. It zips around our sun at an average of 172,000 kilometers per hour, which is a lot. And interestingly, this means that a year on Mercury is equal to only 88 Earth days because she's coming in hot, she's flying. A Venus day is approximately 243 Earth days long. The bad news is that we would have to wait up to 3 Earth years for a weekend. That's because one day on Venus is longer than its entire year. Whoa, wait. That's crazy. What that means is, so one day is the planet rotates like on its axis, right? And 1 year is it rotates around the sun. So it takes Venus longer to rotate on its axis than it does to rotate all the way around the sun, which I don't even know how that would work, but that is really, really interesting. If you could stand at the Martian equator, the temperature at your feet would be like a warm spring day, but at your head, it would be freezing cold. I want to know why that is. That is super, super fascinating. That reminds me, honestly, of living in Colorado, because I lived in Colorado for several years, and you could be sitting in the shade and have half your body in the shade and half your body in the sun, and you'd be wearing like shorts on one end and a coat on the other end because the temperature difference is so extreme. And I think there's a meme or several memes circulating about that where people are like, just your day in Colorado, which is absolutely a thing. Saturn is the only planet in our solar system that is less dense than water. It could float in a bathtub if anybody could build a bathtub big enough. And NASA goes, better stick with the rubber ducky. That is actually super interesting and super cool because you know that planets like Jupiter are also made out of gas. Like if you can't actually stand on any of those planets because there's no solid ground to stand on, which is sick. But I did not know this about Saturn, and I'm not sure why the gas on Jupiter would be less dense than the gas on Saturn, but apparently Saturn floats, which is pretty cool. Oh, also, fun thing about the planets that I remember less from my astronomy course and more from learning about Greek mythology on my own, something that's very cool is that the names of the planets and their moons actually have a lot of mythological origin. Like I said before, Jupiter is the Roman name for the Greek god Zeus, but what you may not know is that Zeus's moons, the names of his moons actually have mythological significance as well, and they are specifically related to his story. So for example, Jupiter has a moon called Io. Io was a priestess of Hera, Zeus's wife, and Zeus falls in love with this girl. And it makes Hera like super jealous, right? Because you don't want your man falling in love with someone else. And she turns Io into a white cow, which is pretty savage, I gotta say. Pretty cool. Anyway, point being that the story of Jupiter and its moon, actually the two do go together, which I thought was kind of a cool thing about space. I know that's not like a science fact, but it's still a cool fact. Ooh, ice giants. Uranus and Neptune. So Jupiter and Saturn are known as gas giants because compositionally they're made up of a whole lot of hydrogen and helium gases. The ice giants, Uranus and Neptune, are compositionally very different from that. So our ice giants are composed of some hydrogen and helium, like the gas giants, but they also contain heavier elements such as oxygen, carbon. But Uranus and Neptune also contain heavier elements such as carbon, nitrogen, and sulfur. Beneath their relatively thin outer shells, these planets' mantles are largely made of compressed, slushy water and ammonia. That's so weird. That's so different from the Earth. I'm sure you know that the Earth's mantle is made up of a bunch of molten rock and it's super hot. But instead, Uranus and Neptune have a mantle made of water and ammonia. One of my favorite thought experiments. One of my favorite thought experiments is to think about how life would be different had we been born on a planet like Uranus or Jupiter. And I know obviously like there's a lot of scientific things that go into that, and there's plenty of science fiction authors that have done that. But I love thinking about that, about how the environment shapes us as humans, either behaviorally or physiologically. So I think a really obvious example is on Earth, we're able to stand on solid ground, but imagine if we were a species that lived on Jupiter, where there is no solid ground to stand on. How would we evolve or adapt in a way that would allow us to exist in that kind of environment? How would someone's body be different? How would we move? Things like that. I mean, would we have to be free floating or flying? I mean, just think about like, it would make a completely different environment. And then you could go into how would people create settlements in a place like that, because you can't build something on solid ground like a house. So how would you find your place? How would you find your home? You wouldn't be able to plant things and grow food because soil depends on gravity because it has to stay on the ground and together. So if it's free floating or gaseous, could you plant something in like a gaseous, like would there be a gaseous version of soil? Anyway, stuff like that I think is just so fascinating to think about. And even if you don't have all the scientific knowledge, I do think it's a very fun and creative thought experiment to think about that kind of thing. We are so accustomed and used to the way that everything works on Earth. And I think it really stretches our mind in a good way for us to think about if things were different. Let's go to the sun, because the sun is sick. I loved learning about the sun. The sun is just insane. The sun's gravity holds the solar system together, keeping everything from the biggest planets to the smallest particles of debris in its orbit. The connection and interactions between the sun and the Earth drive the seasons, ocean currents, weather climate, radiation belts, and auroras. We knew about the auroras because I made 2 videos on that, which if you haven't checked that out and you're interested in the northern lights, go check that out. So the next thing that this says I did know. So even though the sun is like super special to us and we're like, wow, the sun is so important and it literally gives life to everything on our planet, which it does, and it's very important, it's actually not that special in the grand scheme of the entire universe. There are a lot of stars like it. And something else that I remember from the astronomy course that I took is that the sun is actually like not that big of a star in terms of comparing to all the different sizes of stars, which is insane to think about because the sun is massive. Like you could actually fit over 1.3 million Earths inside our sun. To us, that's huge. But when you think about the grand scheme of the solar system, the sun's actually relatively small. There are plenty of stars that are significantly larger than it, which is kind of daunting because our solar system itself is so massive. That was one thing that I really took away from the astronomy course that I took as well. And this is kind of a duh kind of thing, but really like hear me and think about this here, that our universe is massive. And we know that. We know the universe is big. But like when you really start to think about how massive it is and how the speed of light, like how long it takes light traveling at the speed of light to travel through our entire solar system and then beyond, and then it just keeps going and going, and you think about how fast it's moving and how far it goes. It's big. It's big. Question that a lot of us might wonder is, why was Pluto downgraded to not being a whole planet anymore? Because it was a planet for a while and now it's suddenly not a planet. So Pluto is considered something called a dwarf planet. Oh, okay. Okay, so to be a planet, you basically have to accomplish three main things. One is you orbit your host star, aka for us that's the sun. You have to be mostly round, and you have to be big enough that your gravity clears away any other objects of similar size near its orbit around the sun. So translating number three, each planet has its orbital track to go around the sun, and space has stuff in it. Things get put in these orbital pathways, but usually the planets have a strong enough gravitational pull that they can kind of clear the debris away from their orbital track. Pluto is not big enough to do that. He does not have a strong enough gravitational pull to do that. So Pluto's got the first two, he's nailing it. He orbits the sun, he's mostly round, but the problem is that he's not big enough to clear away the debris around his orbit. Which, that seems very specific. Okay, well, I think that'll just about do it for today. Thank you so much for joining me on this deep dive into learning about outer space. I had a ton of fun. If you liked this video, if you liked learning about outer space, if you liked the format of this video where we learn together instead of me presenting it in a more kind of video essay format, definitely let me know. If you want to see Jackson come back, let me know. Thank you so much for watching, and I will see you in the next one.